But when you start to read about this project, you can't believe that nobody's made a movie out of the making of the building of the Sydney Opera House. There was so much intrigue, and the architect ended up getting fired before the project was finished, and then he never actually saw the finished project. He was so bitter about it. But it's still, to me, just a remarkable engineering feat, and also, again, just the beauty of the product. Transamerica Tower, built about the same time. What makes this really interesting is that it's built in San Francisco, so that's a high seismic area. And that's one of the areas that as an industry, are really studying all of the connections. How do the precast pieces connect together, and then how are they going to respond in a seismic event? So we've just done some research with the University of California at Davis and a few other universities, where they did a full-scale building with a shake table test, where they replicated the Loma Prieta earthquake to see how the precast would function in that. And so this is a nice early example of taking precast up high on a structure. This is actually a project that Mark's company worked on, called COSI, the Center of Science and Industry in Columbus, Ohio. Do you know anything about this? You want to?
Yeah, thank you, Marty. Yeah, this particular project had some big challenges to it. The Japanese architect, Harada Azazaki, he wanted basically very tall panels that kind of swept back toward the top of the structure itself, which made them very difficult to form and very difficult to transport. So we had to build special forms, and actually, since the panels didn't lay flat, we actually had to brace them on the back of trucks because of that sweeping arch near the roof of the. Oh, okay. Thanks, Marty. These are some of the forms that we were dealing with, as you can see, and this is actually the bracing of the panels when they were going to ship them to the job site itself. From the standpoint of the joints, the other unusual feature of this particular job is typically precast panel joints they're flat and they're caulked with a piece of foam backer rod, and we put the caulking material over it. The architect was very concerned about those joints and what that was going to look like, so they actually came up with a stainless steel. It's kind of difficult to see in this picture, but it's actually a kind of a rounded bullnose shape, but a stainless steel feature that actually was put into those panels between the joints to again kind of give it a different look. On the ends of the building, go back to the last slide, Marty. We actually had a very, again, difficult condition here, kind of like a colothoid type curve. You had actually sweeping upward back toward the roof, and actually radius and curving around on the ends of the panels as well. So again, a very, very challenging architectural precast project.
So that's my seventh wonder of my 7 wonders of precast. And I just think it's kind of fun when you're starting to think about a product, kind of how do you take it to the limits? What can you do with it that's a little bit different? But most of the projects that you work on, if you're working with precast concrete, you're not going to work on that. But I always think in terms of the design and construction as being kind of like making music. I'm a musician by avocation. That's my other interest. And I think that designers and contractors do a lot of things that are very similar to what musicians do. You're working within this construct. You're working within the framework of, either the white keys and the black keys and how you put those together, or you're working within what pieces of the precast you put together and how they end up looking. And as you see from the projects that we just looked at, it can look very different. They can function very differently, but they're all pretty similar products. And I always like to think that, either with those products, you're either doing something like Handle or you're doing Metallica, but you're still working within that same idea. So what are the different products? Well, this is a little animation that shows you all of the different precast products that you can use in precast structure and frame building. So you start out with the interior wall panels and columns and beams, and you can actually even use precast stairs. In this building, they have spandrel panels that are also functioning as part of the structure, because then you're going to have your double T's rest on there. You can see you've got the spandrel panel, and then they've got corbels coming off of there, and the stems of the double T's are then going to rest on those corbels. So there's different ways of doing that. Sometimes you can do the same idea with hollow core floors, where you might have a shelf that you create to put that together. But this just shows you how all of the different pieces of precast fit together, and then you can have an entire precast structure or frame. You know, our industry would love it if every building used this kind of structural system, but you know, more often than not, we're working within you know, the best practices for that building. So you're maybe putting architectural precast on a steel structure or a cast in place structure. Sometimes it's on a precast structure like this, but this at least gives you an idea of what some of the different products are that come together. And there you've got your HVAC. It's hanging off the bottom of the double T's. And then you come out, put the windows in. So 3 minutes you can put up a building. That's one of the great things about precast. Maybe a little slower than that, but it is something that you can you can build with it pretty quickly, and you don't have to have a lot of things like winterization of the site. You don't have to do weatherproofing. You don't have to have a lot of materials on the site. The precast comes to the job site, gets taken off the truck, gets put right on the building. The truck drives away, and you know, that's what you have. You don't have to have a lot of scaffolding. What you really need is just that crane out on the job site. So I thought I would take you through what the different products are that we offer as an industry. Probably the most common product that you're going to see is hollow core. Hollow core comes in widths of 2 feet, 4 feet, and 8 feet. Typically spans about 30 feet, although you can span up to 50 feet with it. And you can also get floors that are anywhere from 6 inches deep to 16 inches deep. But typically they're about 12 inches deep, and they span about 30 feet. So you can see they've got those holes in there. They've got the hollow cores, which is why it's called hollow core. Anybody want to take a guess as to why you put those cores in the middle of the panels? You're too juiced up on pizza to think? It's the weight. You don't need the weight of the concrete for the strength. So the precaster will take out that weight, makes it easier to ship them, and they still function very well. Double T's. All right, here's an easy question. Who can tell me why they're called double T's? That's it. Ah, all right. You guys are still awake. Yes, it looks like 2 T's next to each other. So you've got your flange across the top, and then you've got your stems coming down, and it looks like 2 T's next to each other. Those are typically going to be 12 feet wide, and they can span about 60 feet long, but you can span anywhere up to about 110 feet with them. What you do when you start getting longer pieces is you usually have a system where you put the wheels on the front, and then you almost use the double T as the truck bed, and then you put wheels on the back of it, and so you don't actually put it on a truck bed. You just transport it with the 2 wheels.
Just a quick comment is actually some things have been innovated in the industry. High Concrete in particular was one that helped innovate a 15-foot wide double T flange, and they're also working on a 16-footer. You're probably wondering, how would you ship a piece like that? It would overhang the truck, and they've actually come up with a kind of a tilt brace, if you will, that kind of tilts the T over diagonally, which allows it to go down the road. So again, that's one of the bigger innovations in the industry. What that allows you to do is have wider base spacings and eliminate more columns, and helps make for a much more efficient design in some cases.